Our next topic about the planet Earth is its magnetic field. Since ancient times, people have known that there were certain kind of rocks, lodestones, that you could dig up and they would align and point north or south. Now, these sort of things turned out to be great direction finders because if you're someplace where it's cloudy, you can't see the sky and orient yourself by the stars, then this would help you figure out which way was which. And so this turns out, though, that they discovered that two different lodestones, one end had a north side, one end a south side. When they put the north sides towards each other, it repelled, light side, south side towards it repelled, the north south sides attracted each other. So it didn't take very long until physicists eventually realized that the Earth itself acts like it has a giant magnet on the inside. And so you have this giant magnet, and then as you've got this huge magnet right here, that what's happening is the magnetic field. In fact, if you just take an ordinary magnet and sprinkle iron filings around it, they line up in shapes like this big magnetic field here. So the magnetic field lines here are coming out here of the south polar area, going into the north polar area, but the magnet is tilted a little bit, so it doesn't line up exactly with the north and south pole of the Earth. So you have the north pole of the Earth, the geographic north pole. The geographic north pole here is the actual north pole of the Earth. The geographic south pole is the actual south pole of the Earth. And the magnetic south, now what happens is that on maps it's normally listed as the geomagnetic north pole or the geomagnetic south pole. And that turns out to be an important distinction there about the geo part, the geomagnetic north, geomagnetic south, because I just said that what happens is that the north end of a magnet is the end that points towards the north. The south end of a magnet points towards the south. But we had also just said that the north poles, that two north poles repel each other and two south poles repel each other. So what does this mean for us? Well, what it means is, so what that really means is that since the like poles, the north pole of a magnet is pointed towards the geomagnetic north pole, that means that the geomagnetic north pole is actually going to be a magnetic south pole. And the geomagnetic south pole is magnetically a north pole. So it acts like that there's a big south pole and a big north pole here on Earth. So that's why the north end of a magnet points that way, is that that's magnetically a south pole. And so this is, if you think about it, that kind of makes sense as to why that would be the case. But that's how we sort of think about it. That means that the way the maps are labeled are normally incorrect. And the way that previous graphic that I labeled right there, which is one that's typically found in textbooks, that too is incorrect because it's labeling the magnetic fields kind of backwards from the way they are. So this graphic here actually labels everything correctly. Again, here it is labeled correctly. So it's a magnetic south pole, and that the magnetic south pole, where the magnetic south pole lines up here with where the magnetic south pole lines up with the surface of the Earth, that is the geomagnetic north pole, or the north magnetic pole is really a magnetic south pole. Okay. Well, they're not lined up exactly with the geographic poles. So the geomagnetic pole is off a little bit, which means that if you are somewhere on Earth, your compass points not towards the North Pole, but your compass points towards the geomagnetic pole. And so that means there's this magnetic declination. Now, in certain places, then they line up just right. So they line up in the right spot, but in other places, they're off by a little bit. In some places, they're off by a lot. For example, out here in the mid-Atlantic, here, from about Bermuda down to Florida and then over a little bit, that area in there, the magnetic compass actually does not point north. It points quite a long ways away from north. And so if you're trying to navigate by compass in that area, you're going to tend to get lost. Likewise, if you were up in Alaska, then that's another place here where the compass doesn't really point towards the north exactly. And so again, you can get kind of like pretty well lost in places like that. Another place where there's quite a bit of discrepancy is the South Pacific. And so down in the South Pacific, there's another area where it really doesn't line up very well. And so again, navigating by compass would tend to get you lost quite a bit. And again, south of Africa, again, that's another place where the compass and the magnetic field or compass and the actual direction are quite a bit off. Airport runways are labeled by magnetic heading, not by actual geographic heading. And so a runway 9 is really 90 degrees azimuth magnetic. So it's 90 degrees. It means it's where it means that it's east on the magnet, not necessarily east geographically. Now, right across the central portion of the United States, then there actually is zero declination in there, and things do kind of line up properly. Okay. Now, something about this graphic here, it's actually by date. Okay. And so by date, this shifts. So right here, the zero line in 2010 ran right, down the Mississippi Valley. But what happens is that the magnetic poles shift slightly. Now, if you go to this website down here at the bottom, then that will give you a way of figuring out. You can input your exact latitude and longitude, or input an address if you wanted to, and it would figure out your latitude and longitude. And it would give you the magnetic declination for that particular location on that particular day of that year. So I did this, about a year ago, and so right at TCC Northeast Campus, the magnetic declination was about 3 1/3 degrees. So 3 degrees, 23 minutes. And so it actually shifts a little bit every year. It's shifting about 20 minutes, plus or minus about 20 minutes. It's shifting about 6 minutes westward every year. Okay, so that means that the compass is actually pointing a little bit to the east of due north, but every year that shifts a little bit, so the compasses are getting closer and closer to pointing north. Airports have to keep track of this because every now and then they have to renumber and rename the runways if this shifts too much. And that actually has happened.